Okay, so we're going to take a look at number 2, the other open-ended, from the exam resources. So this one involved you designing your own experiment to basically determine if energy is conserved, mechanical energy rather, because it's asking about the direct translation from gravitational potential to kinetic energy. So in part A, you're asked to choose the equipment that you would use by putting a check. So according to College Board, you have to put meter stick and stopwatch. As long as you put those two, you get credit for part A. Depending on what experiment you're thinking of, so if you think about the one that we sort of did in class, you would basically need a cart, a track, the meter stick, a stopwatch, and an electric balance. Okay, so basically we'd set up a ramp. With the cart on the ramp, we need to measure the important values that we're calculating or determining. So initial height is very important. Okay, we'd need to know mass, delta X, which is not easy for me to write on here using these tools, unfortunately. There we go. So delta X, the height, the mass, and then the final velocity. So this denotes that you know you need to use the time to find the final velocity, okay? And you know that the height will determine the gravitational potential energy. It then asks you to basically come up with a procedure. Okay, so this is really difficult to write on here. But basically, we would use a meter stick and an electric balance. Yeah, this will take me a year to write this, so I'm just going to say it out loud. You would use a meter stick and an electric balance, okay, to measure. You need to know the mass of the cart, the length of the track, and the height of the track. So my first step would be use meter stick and electric balance to measure mass of cart, height of track, length of track. Okay. 2, release the cart from rest at the top of the ramp and time using the stopwatch how long it takes to reach the bottom. Okay. 3, calculate potential energy initially and kinetic energy finally by evaluating the velocity at the bottom of the ramp. Okay, so basically as long as you include some reference to needing to measure delta X and using a stopwatch to find time in order to get velocity, you get points for that. Okay, you also get points for in your procedure and in your diagram denoting that you need the height of the ramp. Okay, because that basically informs the grader that you know that you need to find gravitational potential energy. Okay, so you want a quick procedure that explains exactly how you'd set up the experiment. Okay, so in part C, it asks to give a detailed account of the calculations for gravitational potential energy and translational kinetic energy before and after the transformation in terms of the quantities that you labeled in part A. Okay, so if you used a capital H in A, you have to use a capital H in C, etc. So make sure that the variables are easily identified or translatable from each part. Okay, so points here, what you have to do is basically explain that you know that the object moves with a constant velocity down the incline, in which you don't know that constant velocity. So you have to use equation 4 of the big four, because it's the only big four equation that doesn't include A, to come up with an expression for V. Note that that equation is not on the AP exam formula sheet. So you would have had to have it memorized to be able to come up with that quickly, or you would need to use a system of equations to eliminate acceleration. Okay, so delta x equals v plus v naught divided by 2 times t. We know that v initial is 0 because the kinetic energy initially is 0. It should be released from rest. So that's going to be 0. So we have v divided by 2 times t. We need to get v by itself. So we'll multiply both sides by 2, divide both sides by t, and you need to have an equation for v in terms of the variables that you have labeled in your diagram. So you'd find delta x, or you'd find v by multiplying delta x by 2 and dividing by t. You'd find the initial gravitational potential energy by taking the mass that you measured, multiplying by 9.8, and then the height of the ramp. There is no final gravitational potential energy because it ends at a height of 0. There's no initial kinetic energy because it starts with a velocity initially of 0. The final translational kinetic energy will be 1/2 its mass times the velocity squared. Okay, so you can set it up in terms of a data table, or you can write it in sentences. It doesn't specify in the solution guide that it has to be in sentences. Okay, part D. After your first trial, your calculations show that the energy increased during the experiment. Assuming you made no mathematical errors, give a reasonable explanation for this result. So hopefully we're thinking, right, if the energy increased, meaning that we ended with more energy than we initially began with, meaning that there was more kinetic energy at the end than gravitational potential in the beginning. What would that mean? Okay, so if we end with more kinetic energy than we initially expected, what that means is that the object did not start at rest and that it was given an initial velocity by accident in the experiment. Right? Energy can never be created or destroyed. In order for energy to increase, the object must have begun with an initial velocity greater than 0 accidentally, so that after the translation, it had more kinetic energy than initial potential energy. Okay, so that energy would come from not the mistake of not starting the object at rest. Okay, in part E, this error analysis, on all the other trials, your calculations show that the energy decreased during the experiment, which means that you end with less energy than you began with. Assuming you made no mathematical errors, give a reasonable physical explanation for the fact that the average energy determined decreased. Include references to conservative and non-conservative forces as appropriate. So you made no mathematical errors, meaning that all your calculations are correct, all of your measurements are correct. There is no calculation or measurement errors. What would this error be due to? Okay, ignoring friction. So what that would mean is that there must be friction on the incline, meaning that some of the initial potential energy was converted to thermal energy and kinetic energy. Okay, so it would be friction, which is a non-conservative force. What a non-conservative force means is that energy is taken away from the system. Okay, so not non-conservative force. Takes energy out of the system. Okay, so that's kind of a hint there that would be due to friction. Unfortunately, for D and E, right, there are no other logical explanations besides an accidentally initially starting the object with initial velocity, or that the incline had friction that could not be ignored. There is no other valid response because the mathematical errors statement takes away any measurement errors, any errors due to collection, or any errors due to math. So the only way it would be physically possible would be the exclusion of friction or initially starting it from a velocity. Okay, so you must have those answers to receive the credit. In Classroom, there is again a posted answer key or solution guide that they would use to grade your response. So please give yourself a grade so that you can kind of self-assess and identify how well you did on this type of question.